The year is 2035. After decades of research and development, the promise of fusion energy is finally being realized. In laboratories and facilities around the world, scientists and engineers are making rapid progress towards harnessing the power of the stars here on Earth. At the Princeton Plasma Physics Laboratory in New Jersey, researchers cheer as their latest experiment achieves a fusion gain factor of 1.25 for the first time, generating more energy from the fusion reaction than was put into it. While more work needs to be done, it is a major milestone along the path towards a fusion power plant. Celebrations erupt across the country as the news spreads. Meanwhile, at the International Thermonuclear Experimental Reactor, ITER, in southern France, the massive tokamak reactor has been completed after years of construction. Using powerful superconducting magnets to contain and control the fusion plasma, ITER is designed to achieve a 10-fold energy gain. The first plasma experiments are initiated and deemed a success, paving the way for further tests. In China, officials announced to the world that their experimental advanced superconducting tokamak, East, has successfully sustained a fusion reaction for a record-breaking 101 seconds. While far from the minutes or hours needed for fusion energy production, it represents a huge leap forward. Chinese scientists speculate they could attempt longer reaction times within the next 5 years. As these projects advance fusion science, governments and private companies ramp up efforts to build the first fusion power plants. Using the knowledge gained from decades of experiments, several prototype reactors are already under construction. In the United States, a consortium of companies known as ARC received federal approval for a pilot plant based on tokamak technology. Meanwhile, companies like Helion Energy and TE Technologies race to develop alternative fusion reactor designs. On April 18, 2035, the ARC fusion plant comes online in Washington state and achieves its first plasma discharge. Despite some initial instabilities, the plant begins generating electricity using hydrogen isotopes as fuel and produces a fusion gain of 2, generating twice as much energy as required to initiate the reaction. While only operating at partial capacity, it is the first net energy production from a fusion plant. ARC announces they will bring the plant to full power production within a year. The success of the ARC reactor attracts global attention. Following years of theorizing and building the foundations, fusion energy is now a reality. Improvements and upscaling will still be needed, but further development suddenly seems achievable. Fusion could soon unlock practically limitless clean energy. In Germany, a new fusion company, Zeus Energy, receives a multi-billion-dollar investment from the European Union to build the next experimental reactor. Meanwhile, Russia struggles as its own fusion program lacks funding due to economic sanctions. This leaves China and the United States leading the charge. Over the next decade, new fusion plants are constructed as the technology improves. By 2045, there are 23 initial fusion plants operating around the world, providing CO2-free electricity to millions of homes. The plants still have limitations, but fusion energy output grows every year. While some environmental groups protest the plants over concerns about potential radioactive waste, many welcome fusion as a critical tool in fighting climate change and ending reliance on fossil fuels. Fusion energy offers energy security as well, since fuel sources like hydrogen isotopes are abundant. By 2050, next-generation fusion reactors are being built. These will produce even more energy gain using newly developed high-temperature superconductors. Some companies manage to make progress on laser-driven inertial confinement fusion, opening up alternative reactor designs. With the promise of fusion realized, optimism grows about solving the climate crisis. Fusion energy expands rapidly, joining renewable sources like solar and wind. By the end of the century, fusion plants provide clean electricity to billions of people worldwide. creating a new era of sustainable abundance. The dream of replicating the power source of the stars is now humanity's new reality. While there are still challenges ahead, fusion energy technology has finally reached the long-awaited tipping point. Driven by scientific curiosity and ambition, together with an urgent need for clean energy, humanity has managed to bring the power of the stars down to Earth. This breakthrough was not easy, but the possibilities now seem endless. Subscribe.